Hello, my name is Keith Thompson. I'm president of Asheville Civitan Club this year. I'd like to invite each and every one of you to join us for the upcoming television series, Spirit of Civitan TV. It's going to be on URTV, and we're going to be covering some of the important issues affecting our community. We're going to be meeting some of the civic leaders who are making a difference every day in the lives of our community, and making things better for our children and grandchildren, making this a better place in which to live. So we hope you will be able to join us and watch our series as it comes forward. Thank you.
Welcome Rick Wooten, please.
As John mentioned, I'm with the North Carolina Geological Survey, and that's North Carolina Geological Survey, not U.S. Geological Survey. We get mixed up a lot, but we're the home team. We have an office here in Asheville, and we're actually part of the Department of Environment and Natural Resources. I'm going to talk to you about landslide hazards in the mountains, and when you have mountains, you have landslides. It comes with the territory. And part of the program that my group is working on, 110%, or developing landslide hazard maps, countywide landslide hazard maps for western North Carolina. I need to tell you a little bit about the North Carolina Geological Survey. Again, we're a state agency. We've been around since 1823. But our job is to map and describe the geology and the mineral resources of North Carolina and encourage their conservation and wise use. And most importantly is to provide accurate, unbiased information for societal needs. Basically, some statistics for starters. Since we've been keeping informal records since 1990 and more formal records since 2004, there have been 6 landslide fatalities in North Carolina, 45 structures destroyed or condemned, and those are primarily homes. And you can see the pictures of some of these homes here that are pretty well demolished, some almost beyond recognition. And one of the very important issues that we deal with here in the mountain, as you well know, with mountain development and modifying slopes, those landslides that have occurred on modified slopes, we've had 1 fatality and 28 structures destroyed or condemned. We all really got started on this program after Hurricanes Francis and Ivan came through in September of 2004. This is Hurricane Ivan here. You can see it was a big one. And one of the reasons we have landslides in the mountains, the heavy rainfall triggers those landslides for the most part. And I'll talk a little bit about that later. Since we've been doing the inventory from Francis and Ivan, we have information that those 2 series of storms that occurred back to back have triggered about 400 landslides. And that's a recent update. The number we've tossed around up until last month was about 155. We've since got some information from the U.S. Forest Service, and they've had almost 300 on national forest lands in North Carolina from those 2 hurricanes. There have been 5 fatalities from Francis and Ivan and landslides, and those were the victims at Peaks Creek. 27 homes destroyed or condemned. As a result of those storms, the North Carolina General Assembly passed the Hurricane Recovery Act of 2005, and that authorized us to make landslide hazard maps for 19 western North Carolina counties. So that's the program we're doing right now, mapping those landslides. As part of doing the countywide mapping, we also have developed a regional landslide inventory, and all the dots on the map there, just about 5,200 of them are the landslides or landslide deposits that we've identified in this mapping. To give you an idea where the landslides occur geologically, the geologists, we divide North Carolina up into 3 major provinces. The coastal plain here, those are the relatively young, geologically speaking, deposits that were left behind when the sea level was much farther west than it is now. And this is the Piedmont and the brown, the central, rolling topography of the Piedmont. The Blue Ridge geologic province, and that's where the steep ground is, and that's where most of the landslides are. When I go through some of the different types of landslides, when we're being technical, we call them slope movements, because sometimes the material that moves is rock, sometimes it's soil, sometimes it slides, sometimes it falls, sometimes it flows. So when we're trying to be technical about it, we break it up into different categories, but they're all generally referred to as a type of landslide. The first one here is a rock slide, and this occurred during Tropical Storm Cindy in July 2005, and this is the Broad River Fire Department down towards Lake Lure, still in Buncombe County. And this is about a 50-ton chunk of rock that peeled off this slope here behind the fire department. And did considerable damage. And when we're analyzing rock slope stability, it's the cracks in the rock that are important. And these are shown as these little lines in the cartoon here. And water gets in along these cracks, and depending on how they're oriented, if they're tilted so they go out of the slope, that provides a slip surface or a failure plane for these rock chunks to come out. And so it's pretty standard geotechnical practice to look at a rock slope like this and measure those fractures, estimate or test the strength of the rock, and so you design a cut slope in that so this doesn't happen and then this doesn't happen. This is the new back door they got during Hurricane Cindy. Probably the most numerous type of landslides that we have here in North Carolina. The most dangerous are what we call debris flows. And this is a type that originates on a steep hillside, usually up near the ridgetop, but not always. And when they flow, it's because there's an enormous amount of water that's mixed in with the soil. So it's really this thin soil layer above the bedrock. For the most part here, the bedrock is relatively stable. When that upper soil gets saturated to the point where it starts to flow, then it moves down, incorporating and building up, snowballing as it goes down the hill, typically finds its way down a drainage path and ends up at the bottom of the hill in a feature we call a debris fan. And these debris fans are very common in the mountains, and that's one of the features excuse me, that we're mapping to get an idea where landslides have happened in the past. And these fan deposits often are quite large, and they're the buildup of multiple landslides events over geologic time. So how does this happen? So if you start up here on a hillside with bedrock here and a shallow soil horizon, usually less than 6 feet, trees growing on it, because the roots in the trees, those are important stabilizing factors for hillsides. And you get rain coming in, and it builds up this shallow water table at the contact between soil and rock. When it gets up to the point where it's too high, it exerts, for the engineers in here, an uplift force along this contact, and the pore water pressure actually pushes the soil grains apart and overcomes the shear strength of that material, and it starts to fail, develop slip planes, and with enough water, when that disturbance occurs, it begins to flow. And then everything goes away down the hill, and that's what happened at Peaks Creek. So why are debris flows so dangerous? Well, in the case of Peaks Creek, there were 5 fatalities, 16 homes destroyed. They typically occur without warning. This particular one happened about 10:10 at night during Hurricane Ivan. Electricity was out. And so it comes roaring down from Fishhawk Mountain down the yellow line here, which is the pathway to the inhabited area of Peaks Creek. And this is Wayne and Marilyn Jones' house, which is right about here. And it used to be about 30 feet over here and about 2 stories high. So the reason these are so dangerous is they travel very rapidly. This one, we've estimated the velocity to be on the order of 33 miles an hour. That's 45 feet per second. So that's about across this room in a second. So that means it's going to be very tough to outrun these. And in terms of discharge, the amount of material that's flowing at a given time, it's about 70,000 cubic feet per second, going by at about 33 miles an hour. This is some of the deposit from the 2004 event. These big boulders here are about 16 tons. This is one of our geologists here. She's about 5'6". So if one of these is going down the stream 33 miles an hour, not much is going to stop it. Some interesting historical aspects of the Peaks Creek debris flow. This is Fishhawk Mountain again. This is the south side. In 2004, it went off the north side. Interestingly enough, T.L. Klingman, who's the namesake for Klingman's Dome in the park, wrote an article in 1877 about what he called water spouts, but by his description, they were debris flows that came down the south side of Fishhawk Mountain. So what we found in Macon County, and we find over and over again, is that where debris flows had happened in the past, they typically happen in the future. Now, we don't know what the timing is, but it's an indication of where that activity's occurred in the geologic past. A little closer to home here, debris flows in Starnes Cove during Hurricane Ivan. In this particular case, we're looking at a situation where it's an old logging road at the top of the hill here, and those embankments or the fills on these roads failed. And, the road construction here was probably a contributing factor to this. And these paths converged in the direction of the arrows here. And if you go downhill, this is the path coming around the bend here. Here's Rebecca at 5'7". Here's the mud line and the trees from when that went by, and it's about 35 feet up above the stream channel. So when that goes down the hill at 33 miles an hour, that's the first house that went by. It did some pretty serious damage to the truck, really messed up the stream. The second house was totally demolished. So let's switch a little bit and talk about some of the characteristics of debris fans. This is what they look like from the ground. We saw, some other pictures of gullying out, but if you step back and look, this is in the Maggie Valley area. The area outlined in green is a debris fan. It's a nice, gentle slope, and this is an apartment complex built on the fan. This is the source area. This particular one's been around for a long, long time because these boulders have weathered to the point where you can crumble them with your hand pressure. The other reason we map these debris deposits, other than indicating where there's been past landslide activity, we're looking at thick, unconsolidated sequences of sand and gravel and clay. And so they're not stable like rock. They are just in the undisturbed state, but if you cut too steeply into them, it can fail like it happened in this case, and it pushed this house about 4 feet off its foundation. This is a great testament to the guy that built this log cabin because he just hitched his tractor back up to it and dragged it back onto the foundation and puts in the retaining walls. Another type of landslide we have is what we kind of kiddingly call big slow movers. These are not rapidly moving landslides like debris flows. This one, it occurs outside of Waynesville. It's probably moving on the order of maybe inches per year. Very, very slow. And it's an area outlined here. This is an aerial photograph looking down. These are houses here. It's about 1.5 acres, moving downhill in this direction. And these areas outlined in red are scarps. That's where the ground's actually being pulled apart. 50 feet deep, if you look at a slice through the middle of it, this distance is about 50 feet down to where we think this failure surface is. And it's about 65,000 cubic yards of material. And the engineer's estimate to stabilize this is about $1 million. And that's a lot more than most homeowners associations can afford. This is what the homes that are being damaged looks like. This is the basement at one of the homes at the top of the hill. You can see the crack going across here. That's about a 2-inch gap in that cinder block wall that's about 10 feet high here. Things that are normally plumb or vertical or not, like this leaning car post right here. This is a terracotta drain pipe at the bottom of the hill. Things are being squeezed together and crunched at the bottom of the hill. This is sheared off. What you see here, this is actually a bulge. This is the blacktop driveway. And this is the slab for the foundation in the garage. And so this slide is pushing this slab forward, so it's making this big bulge in the driveway here to the point where the lady and the guy that lived there weren't able to get their car in. I'm going to switch gears here a little bit and talk about some of the products. Our products are, again, the statewide database, some statistical information. The main product are the maps. And I'm going to go through a series of maps for Watauga County. We just finished that. It's a landslide map. We use the long-term slope movements and slope movement deposits. A geologic hazards map. There's certain formations here in the mountains that, because of the sulfur content, tend to produce acid when they're opened up and exposed to rainwater. There's some potentially unstable rock slopes in the vicinity of some of the faults. Not because the faults are active or anything. It's just those rocks have been beat up pretty badly, and they've got a lot of fractures and cracks in there that make them unstable if the design and construction isn't done just so. A stability index map, and that's one that the color codes, it ranks, the relative higher potential debris flows occur where it's red, the much lower potential is where it's green, and a debris flow pathways map. So this is where landslides have happened or are happening, this is where they might start, and this is where they may go. So some of the statistical information, and one of the key questions that comes up, in the discussions and debate about slope regulations and land use ordinances and those sorts of things, what constitutes a steep slope? Well, our information that we've plotted up to date where we've been on the ground and measured the ground slope at 330 locations where there have been landslides, that occurrence starts to pick up at about 20 degrees on the ground, in that range of 20 to 25 degrees, and that's roughly about 40%. So how do we make these maps? Let me run through quickly. We spend a lot of effort on looking at old aerial photography, 1940 photography, Watauga County, 1951 and 82 for Buncombe. In 1982 photography, we can see a lot of effects of the November 1977 storm. So we can step back in time and see where these have happened. So in producing a landslide hazard map, all the dots on this map are landslide locations where they started. So if we zoom into this area Boone sits right about here. This is 421 going down towards Wilkes County. Here's the Blue Ridge Parkway. The magenta-colored stripes, those are old paths of debris flows, and the pumpkin-colored material are the old debris deposits that actually existed before these happened in 1940. So that tells us, where things have happened in the past, but it doesn't give us a really good idea of the potential problem areas in the future. And this is the stability index map. This is that same area that we looked at. So one of the reasons we map these debris flows and the yellow squares indicate where they originated is this is a predictive model. When you're trying to predict Mother Nature, it's pretty tricky business. But what we want to know is the areas that are predicted to be unstable, and those are the areas that are red and this dark color on the map. We want to see a really good correspondence between those areas and where they've happened in the past, because that's the way we calibrate the input parameters for this model. And it involves slope, hydraulic conductivity of the soil, the thickness of the soil, the shear strength, and information that's used to actually compute a factor of safety. I know you can't see the numbers there, but it's based on a computation at each point on this 20-foot grid. And so thank goodness for computers. There's no way we could do this by hand. The downslope hazard map, that's where the debris flows are likely to go. And I pulled a little trick on you here. I switched over to Macon County. We've been looking at Watauga County. This is an area on Nickajack Creek. And so if you zoom into this map, these are the pathways shown in red here that we use the computer to predict or to construct flow lines from these points on the map that are unstable in the high hazard areas. So those are potential places where they might start. And because of the high resolution digital elevation model that's from the LIDAR, which is that airborne laser altimetry, it's this long word, but it gives us a lot better perspective and view of the topography than we've ever had before. So that computer can give us a really good idea what the direct path downhill is from each point in these. And you can see they converge in the stream paths. And so this area here would be the high hazard zone, as shown in red. And this is an old debris flow deposit here, this big rocky material. Now, these boulders are kind of stacked in here shingle style, and that's a very classic indicator of that those were deposited by a very large debris flow flood type event. And so, these deposits that are in higher ground up here, they're elevated above the areas where the younger debris flows might go. But because it's happened in the past up here, and we know from examples in Virginia and Watauga County, North Carolina, sometimes modern debris flows will come down here and they'll just come out across the top of these deposits. So it's a higher probability down here, but we can't be ruled out for some of these locations up here on the top. So Watauga County, let me wrap it up here with some putting things in perspective here. In August 13th through 14th of 1940, this storm that's outlined in green, it's a hurricane, came through most of the southeast and caused flooding all the way from Georgia, Tennessee, into the Carolinas. It triggered about 2,099 landslides in Watauga County, and those are all the black dots on the map. What we learned in Watauga County, surprisingly enough, in 2004, when Francis and Ivan came through, 15 of those debris flow tracks that were active in 1940 reactivated in 2004, and that's a pretty quick turnaround time. And from the geologic studies that have been done, typically we think of hundreds, if not thousands of years between a particular spot that if it fails before the soil accumulates again and conditions are ripe when another big storm comes through. But in Watauga County, about 15 locations, less than 1%, reactivated. In this particular case, you can barely see it, but the 1940 pathway is in orange and the 2004 pathway is in yellow. In this particular case, it's related to a road embankment that was built in this area that failed in 1940. So one of the idea with these maps is it's not to say you can't build in certain areas, because number one, we're not regulatory, and number two, they don't substitute for a site-specific investigation, but it points out areas where you need to take extra precautions to make sure you get that road design, road location right, so you're not causing problems for yourself or people down here. The other thing that we've learned in Watauga County since 1940, about 136 homes have been built in the pathways of those debris flows that happened in 1940. And so these are the locations in red that are located inside or right on the border of these pathways from 1940 landslides that are outlined in orange here. So I doubt very seriously that these folks built the homes in these locations with that kind of information at hand. So one of the reasons we're doing this mapping is so people have that information available to them when they're looking for a place to build in the mountains. So zooming into Asheville a little bit, closer to home, we're doing work in Buncombe County right now. Look at debris flow deposits. If we go out the east side of the county in the Black Mountain Swannanoa area, these areas that are pumpkin colored are some of these debris fan deposits we've been able to map. And the field crews have been out doing field work in this area just recently. And this is the preliminary stability index map. We're here in Asheville, and there's a lot of green. That is very good. Really, the only areas that have some potential, these are the Elk Mountains right up in here. This is the Bowcatcher Cut coming through 240 there. So this doesn't mean landslides are going to happen. Number one, it's a preliminary map. We do this before we start field work with some rough information so we know what parts of the county we need to concentrate our efforts in. So anyway, these are the steeper areas around the county, as you might suspect. So this gives us a rough first pass of where we need to concentrate our field work in. So this map is on hand at the Buncombe County Planning Office, just for their information. So we hope to have Buncombe County done sometime this summer. We go back to Starnes Cove in this area we talked about earlier. This was the house that was destroyed. These are the initiation points, and shown in blue here for those landslides. So we were, glad to see that we're getting a correspondence between areas where we've known there's been, landslides and unstable ground and where they've actually occurred. So this is the kind of information we're trying to get out and make available so folks can have that in the event a big storm comes and they haven't some sense if they are in a hazard area or when there is construction going on, so they can evaluate those potential slope stability problems in advance of making a major commitment of resources. So summarize, I'm going to wrap things up here. The maps are delivered to the county, a geographic information system, so they can use it in their planning. You look at parcel boundaries, critical facilities, utility lines, all those kinds of things. They're not regulatory at this time. Again, we're not a regulatory agency. There's legislation that's been proposed that links the requirement for future landslide studies or slope stability studies for areas that are indicated as high hazard in these maps. Now, they can be used at the parcel and parcel group level. You've seen from some of the aerial images, you can see locations where there have been past landslides relative to houses and roads and trees. But it's not the final word at that. These maps point out areas, these maps do not substitute for a site-specific investigation. This is a rapid first assessment. But it tells you, where this kind of information or investigation is warranted, where there's, based on what we know now, there's the potential for instability in these areas. It does provide the big picture perspective beyond the site. When you're working for an engineering firm or a development, a lot of times, you get paid for working on that particular piece of ground. This gives you an idea of what's upslope that may, affect your property, or if something goes wrong on your property, who may be in harm's way down below. And of course, it's a planning tool for, local governments, emergency management, the public. And Macon County is complete, Watauga County is complete, Buncombe is in progress right now, and right now the schedule is to go to Jackson and Henderson County next. And just to wrap things up, this is what, going back in history, this is the flood of 1916 in Asheville, the mid-July storm. This is the water line and the train station. I've heard Asheville has been called the Paris of the South. I think, and this time it was probably closer to the Venice of the South here. And there was another storm in 1940, the latter storm. It really hammered Jackson and Haywood counties, and there were a lot of landslide and flooding fatalities in that area. Here's a house that was damaged by flooding or a debris flow, we're not sure which. So going through time, how often can we expect this kind of thing to happen? Here's the map that shows paths of the hurricanes, and that's usually the major events where we get the heavy rainfall that triggers, debris flows and other kinds of landslides across the region. If we look at time, going back to 1901, when we have some first recorded rainfall information for landslide occurrence, and going out here to 2005 to Hurricane Cindy, this is rainfall on this column, this is time. So in the 1916 event, there was an early storm in early July, very much like Francis and Ivan. This would be the equivalent of Francis, and the second storm like Ivan comes through except this storm dumped about 22 inches of rainfall in 24 hours at Alta Pass. Back-to-back storms again in August of 1940, a major storm in 1977, and again Francis and Ivan. So that recurrence of major storms or back-to-back storms in the region, it's about every 22 to 29 years, however you do the math, and that's about once every generation. And so that's good in that it's not every year like some places in California, but it's plenty of time for people to forget. So the other thing here is this is the 5 inches in 24 hours rainfall line. So that's the threshold. When we see that the prediction for that much rainfall coming, that's when we get together with emergency management and the National Weather Service and make a call on whether it's appropriate to issue a landslide advisory. So that's kind of a threshold value there. Like all rules of thumb, there are exceptions. It turns out that probably the key thing for rainfall and landslides, if that's 5 inches spread out evenly over 24 hours, it's not necessarily that big of a deal. I mean, it can be. But in this case, in 1951, there was 4 inches of rainfall that came down over Mount LeConte that triggered lots of debris flows. It was about 4 inches in an hour. So that rainfall intensity of that is particularly dangerous here because that's a summer storm that comes up in the summer. It's not one we've been tracking on the Weather Channel for a week and know in advance it's going to be getting here. So to put things in perspective, what we're looking at here is rainfall rate and duration. That's called intensity. So from the folks at the U.S. Forest Service at the Coweta Hydrologic Station, we got some really good rainfall data from them in the timing for that period where we know at least 2 debris flows occurred in Macon County, and that was Peaks Creek and another one. And that rainfall that right before those debris flows occurred was about a little over 4.5 inches an inch per hour for about 4.5 hours. So it's about an inch per hour for 4.5 hours. And that was that big wave, spiral rain band that came through right before that happened. And if we look regionally, the numbers of the landslides from these 2 storms, Francis and Ivan, was about 400 that we know of right now. In Watauga County in 1940, that was about 1 3/4 inches per hour for 6 hours. That's the peak rainfall for that storm. And now we're at Watauga County. We documented about 2,100 landslides. From looking at some of the photography in Wilkes and Caldwell County, I think that number is probably going to exceed 3,000, perhaps even 4,000 by the time we get that work done. In the Madison County storm in 1995 in Virginia, 629 debris flows. The winner, or the loser, the really bad storm, was actually Hurricane Camille in Virginia in 1969. That's the same storm that tore up the Gulf of Mississippi, much like Katrina did. But when it tracked over Nelson County, Virginia, it triggered close to 4,000 landslides, mainly debris flows, and killed something on the order of 150 people. And that was about 3.5 inches of rain per hour for 8 hours. And so, I count myself as one of those people that when we heard all the stories about New Orleans, and I said, well, yeah, they should have known this was coming. They should have been prepared. When I look at myself in the mirror in the morning and ask, well, are we prepared for this kind of event here in Western North Carolina? I have to say, I don't think we really are that well prepared. I don't know how you could be prepared for something like this, but let's hope it doesn't happen. It may never happen for 500 years. It may be next hurricane season. We just don't know that.